All right, solving quadratic equations. There are three methods that you can use to solve a quadratic equation. So remember, a quadratic equation generally is one that is in the form ax squared plus bx plus c equals 0. Okay. I'm going to look at three methods. So the three methods are factoring, what's called separation, that requires knowledge of completing the square, if you don't have the proper form. I will link to my completing the square video in the description of this video. And then the last one is the quadratic formula. Each method has its pluses and minuses. Factoring tends to be the go-to method, but not all quadratics factor. The other two methods will always lead you to a solution if the quadratic equation has a solution. All right, so factoring, because not all quadratics factor, there's a limited number of quadratics that this is going to work on. But if you have a quadratic that factors, this is going to be the way to do it. So I'm going to start with factoring. Now, I'm not going to teach you how to factor here. I'm going to assume you already know how to do that, though I'll give you some hints along the way. The first thing you need to know about this method is it's based on a theorem in arithmetic called the zero factor theorem. And what that says is, if I have a product, say a times b, that is equal to 0, then that means that either a is 0 or b is 0. Basically, the only way you can get 0 by multiplication is by multiplying by 0. And 0 is the only number that that's true for every single time. Okay. All right, so if I have, let me see, what have I got here? Let's take a quadratic equation. X squared plus 8x plus 12 equals 0. All right, so I know this factors, so I'm going to try and factor it. So what I want here is, right, two binomials. So to get the x squared, I'm going to say x times x. And then I need factors of 12, two numbers that multiply to be 12, that also add up to 8. So 6 and 2 will do it. 6 times 2 is 12, and 6 plus 2 is 8. So if both of these are positive, I've got what I need. And you can always check to make sure you factored it correctly by multiplying those two back together. All right, now the zero factor theorem that I have written above there says, okay, I have a product that's equal to 0. So that means either x plus 6 is equal to 0 or x plus 2 is equal to 0. And now I have two simple linear equations to solve. I'm just going to do that. So I get x equals minus 6. And over here, I get x equals minus 2. All right, now you want to check that. Always check. There has to be a check. And when you check, I mean, it's going to work for the two factors that you came up with. So when you check, always go back to your original equation, right? So I'm going to check this in x squared plus 8x plus 12. And make sure that when I plug those numbers in, I get 0. So minus 6 squared plus 8 times minus 6 plus 12. So that is 36 minus 8 times 6 is 48 plus 12. And that does indeed equal 0. So that one checks. So I know that x equals -6 is one solution. All right, -2 squared plus 8 times -2 plus 12. And so that's 4. That's -16. That's plus 12. And again, add that up. That does indeed equal 0. So that one checks. All right, so as long as you can factor your quadratic, you can find solutions. All right. Now, what you're going to have to do to factor may vary, but basically that's the technique. Okay. So the second technique, what I'm calling separation, involves, you would normally use this if you had a quadratic that was already in vertex form, okay? But it doesn't have to already be in that form. So for separation, right, standard form, what I showed up above, is not the only way that you can see a quadratic. I could, let's say for example, hang on a second. Yeah, let's see what happens when I make problems up on the fly. Say I had something like that. All right, now that is going to be a quadratic. I don't want to have to multiply that out. I don't have to multiply that out and put it in standard form and then try and factor it. Okay. What I can do is to start to separate it. And that is head towards getting all my x's on one side of the equation and all my not x's on the other. So I have a -4 here that's just kind of hanging out on the left. I'm going to move it over to the right. So then we have x minus 9 squared equals 4. Now my x is inside parentheses under a square root sign, under a square sign. So to get rid of that, I need to square root. So if I square root, and I'll just make a little mark here, right, just to indicate I'm going to square root both sides. When I square root the left-hand side, I get x minus 9. When I square root the right-hand side, because I'm imposing a square root, I have to say plus or minus, and the square root of 4 is 2. And now I can separate my x out, right? I can add the 9 to both sides. And I get x equals 9 plus or minus 2. Now, because these are integers, even if they were rational numbers, I could actually find them. So I am going to find them. And we're going to split this up, right? So we get x equals 9 minus 2, and x equals 9 plus 2. So over here, x equals 7, and x equals 11. All right, now I want to check this, and I'm going to go all the way back to the original equation, just like before. All right, so let's see. X is, let's start with 7. So we go 7 minus 9 squared minus 4. All right, 7 minus 9 is -2. -2 squared is 4. And that does indeed equal 0. All right, so I know that x equals 7 is one solution. Right, for 11, 11 minus 9 squared minus 4. So 11 minus 9 is 2. 2 squared is 4. And that is also 0, so that checks. So I know x equals 11 also checks. So if you have a quadratic that's in vertex form, excuse me, there's no need to multiply it all out. Right? You can just use this technique. Now, if you have a quadratic that's in standard form that you can't factor, then one way to solve it would be to put it into vertex form. So let's take a look at one of those. I'm going to take this one. All right, so let's go for 2x squared plus 16x minus 24 equals 0. Now I mentioned at the top of this that in order to do this you need to know how to complete the square, so I will link to my most recent video on how to complete the square and the technique that I used for that in the description of this video. All right, so this is an equation, so it's a little different than completing the square on a function. But essentially the technique is the steps are the same, but because I have an equation, I have another side that I can move stuff to. So I'm going to get my constant term out of the way by moving it over to the other side. So then I have 2x squared plus 16x equals 24. Now the other thing, because I have an equation, I'm looking for the zeros or the solutions to this equation. I don't have to really worry about factoring out a leading coefficient. I can just divide it out because I'm not actually looking for the vertex. So I'm going to divide 2 out of both sides. That means every term. So I've got x squared plus 8x equals 12. Yep. Okay. All right, so now I have my leading coefficient is 1, so I can do my completing the square. All right, so p, 2p, let's forget that too. 2p is 8, so p is 4, and p squared is 16. So I'm going to add 16 to both sides. And the left-hand side is my perfect square. That is going to factor into x plus p squared. So x plus p is 4 squared. And on the right-hand side, I've got 28. That 28's not a perfect square, but that's fine. It doesn't have to be. I can still solve this by taking the square root on both sides. I am now where I was in the previous problem. So I can square root both sides, and on the left I'll have x plus 4. On the right, I'm going to have plus and minus the square root of 28. I don't think I can even reduce that radical. I'm not going to try. And then bring the 4 over. X equals minus 4 plus or minus the square root of 28. This one's a little harder to check, so I'm not actually going to go back through and do the check on this one. If you want to go back and do the check, you would have to put this into your calculator, turn it to a decimal, and get an approximation. Because it's too much to try and put that as it looks through the function. So notice we didn't get a rational number here, because the square root of 28 is not a perfect square. Because we didn't get a rational number, that kind of confirms that our original quadratic up here doesn't factor. Right? But notice, just because it doesn't factor doesn't mean it doesn't have a solution. It just doesn't have a rational solution. So you can still get a solution even if your quadratic doesn't factor. So if you can't factor the quadratic, you have to try another method before you give up and say it has no solution. All right, so the third method for solving quadratic equations is the quadratic formula. And the quadratic formula, I have a video. I will link to the video also in the description of this video where I derive the quadratic formula. All right, so you can see where it comes from. But the quadratic formula says if ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so if I have a quadratic, I want it in standard form, ax squared plus bx plus c. I'm going to pick out the coefficients a, b, and c, and I'm going to drop them into that formula. All right, now the nice thing about the quadratic formula is you can always use it. Right? And there's some clues that will tell you whether or not you'll get a solution. But let's work on a problem first, and let me see what I've got here in my bag of tricks. I could just go back and do the same problem again. All right, well, you know what? I'm just gonna make one up. All right, let's say 2x squared plus 5x minus 1 equals 0. I can pretty much be guaranteed that this is not going to factor, but it doesn't matter. Even if it does, we can still use the formula. All right, so to use the formula, I need to pick out the a, the b, and the c. All right, so a is the coefficient of the quadratic term, so a is 2. B is the coefficient of the linear term, so that's 5. And c is the constant, so that is minus 1. All right, now I'm going to come over here. So x equals, I'm going to follow the formula, negative b, so minus 5, plus minus big square root, b squared, so 5 squared, minus 4 times a, which is 2, times c, which is minus 1, all over, whole thing, over 2 times a. Whoop. I always do that. 2 times a, which is 2. Right? Now, at this point, it's just arithmetic. So I'm going to do a little scribbling up on the top here. 5 squared is 25. 4 times 2 is 8, times negative 1 is negative 8, so that's minus a negative 8, so that's plus 8. So we get minus 5 plus minus 25 and 8 is 33. 33 over 4. All right, now again, 33 is not a perfect square, so I'm not getting a rational answer. I'm getting an irrational answer, but that's fine. All right, if you needed this for anything, you would just drop it in your calculator and you would turn it into 2 different decimal values. Right, so when you get an answer like this, you are getting 2 values, right? We're getting x equals minus 5 minus radical 33 over 4. and x equals minus 5 minus radical 33 over 4. All right, now, like I said, the nice thing about the quadratic formula is you can always use it. And my advice to my students is always, if you can't see how to factor a polynomial in the first minute, just use the formula. All right, now let's look at this formula for a minute. The formula has a square root in it. So the b squared minus 4ac, that number underneath the square root, is going to tell us something about the quadratic. Because I can't take a square root of anything I want. I can't take a square root of a negative number. If that number is 0, then that's going to tell me something. If that number is a perfect square, then that's going to tell me something. All right, so that number underneath the square root sign, the b squared minus 4ac, is actually called the discriminant. Helps you to discriminate between your quadratics. And so all right, and that is the b squared minus 4ac. Now, one of the things you can do if you're trying to determine solutions for a quadratic is to calculate b squared minus 4ac, and that will tell you even whether or not you have solutions. All right, so let's look at this. If b squared minus 4ac turns out to be negative, well, then what do I have up here, right? Up here, I would have a negative number under the radical. I can't have a negative number under the radical, so I would have no solution to my quadratic equation. If b squared minus 4ac, let's say it's equal to 0. All right, let's scroll back up here. So if the square root is 0, then I just have minus b over 2a. I'm going to get one solution. All right, I have one solution. And that is x equals minus b over 2a. If b squared minus 4ac is positive, greater than 0, I'm going to have two solutions. All right, now, if I have two solutions, I have the possibility that I have two rational solutions or two irrational solutions. So underneath this, if b squared minus 4ac is a perfect square, I'm going to have two rational solutions. If it's not a perfect square, I'm going to have two irrational solutions. So when you look at a problem, let's look at a problem, right? I need to decide if, there's a good one. I need to decide if 9x squared minus 6x plus 2 equals 0 has any solution. So let's make this into a question. Does any solutions? Okay. So I'm going to pick out A, B, and C. And I'm going to see what happens to my discriminant. Right, so b squared minus 4ac is going to be negative 6 squared minus 4 times 9 times 2. So this is going to be 36 minus 9 times 2 is 18 times 4, 72. So this is minus 36. That's less than 0, so I have no solution. Okay, so notice I didn't try to factor it before I try and do anything with it. I'm going to check the discriminant to see if it's even worth going forward with. So this one, I don't have to do any more work than that. It has no solution. Let's take a look at another one. Let's see, what have I got here? Now I'm getting too many in my list here that have no solution. Okay. All right, so let's try this one. Or let's try this. How many solutions? Another way we could ask the question. Where is, oh, there it is. X squared minus 8x plus 7 equals 0 have. All right, so notice the question just asks how many solutions does it have, right? It's not asking me to find them. So in that case, again, I'm going to go straight for the discriminant. All right, so B here is negative 8 minus 4, A is 1, and C is 7. So this is going to be 64 minus 4 times 7 is 28. And I almost don't care what that is. 36. Right? It's greater than 0. So that means I'm going to have 2 solutions. Notice it's also a perfect square. So that means I'm not just going to have 2 solutions, I'm going to have 2 rational solutions. And if I have 2 rational solutions, then this polynomial actually factors. Okay. All right, so the 3 techniques that you can use to solve a quadratic equation: factoring, if you're quadratic factors and you can see how to factor it easily; separation, if you have a quadratic that's in vertex form, or you like completing the square. Also, that's fine. You can use separation, and then the quadratic formula. And the quadratic formula, like I said, is nice because you can always apply it. And within the quadratic formula, before you even start a problem, calculate the discriminant to see if it's even worth moving forward with the problem. All right, see you guys in the next video.